Discuss module number 3, the non-homogeneous linear equation with constant coefficients. So under non-homogeneous linear equation with constant coefficients, we have two parts of the solution. The first part is the complementary function denoted by yc, and the particular integral yp. And this comprises the solution y that is equal to yp plus yc. Okay? So that'll be on non-homogeneous linear equation with constant coefficients. So our aim here is to find the value of yc and to find the value of yp. And under non-homogeneous linear equation with constant coefficients, we have two methods. I'll be teaching you two methods. Merong third method pero hindi ko na ibibigay sa inyo yon. Kasi yung mga methods na yan, they will arrive on the same solution anyway. So I might as well give you only two methods. That is, method number 1, that is the reduction of order. Okay? So under the reduction of order, we have the two solutions, that is for yc and yp. So under reduction of order, let me give you an example. Nagluluko yung aking pansulat. Okay. Example number 1. Okay. Find the general solution of d square minus 4 y is equal to 4x minus 3e to the x. Okay? So the solution here should be we have to find the roots of the equation using the auxiliary equation. So what is the auxiliary equation of the given equation? We have m squared minus 4 is equal to 0. Factoring this, we have m minus 2 times m plus 2 is equal to 0. The roots, therefore, r sub 1 is equal to 2, and r sub 2, small letter r sub 2, is equal to negative 2. So we have the two roots, 2 and negative 2. Okay? So, the factored form of the equation, therefore, is d minus 2 times d plus 2y is equal to 4x minus 3e to the x. So, after finding the roots, we may now have the complementary function yc. So how to find the complementary function yc? Okay? referring to module number 2, case number 1. So what is module number 2, case number 1? So we have the roots. We have y is equal to c sub 1 e to the r sub 1 x plus c sub 2 e to the r sub 2 x. Your y that is actually equal to yc for the complementary equation, therefore we have yc is equal to c sub 1 e to the 2x plus c sub 2 e to the negative 2x. So this came from module number 2 sa homogeneous, case number 1. That is your yc. So we have to set aside yc first. Now we'll have to go to the solution for the particular integral, yp. That is a, so that is a b for the particular integral yp. Okay? So, on the particular integral yp, we have to rewrite this equation. We have d minus 2 d plus 2y is equal to 4x minus 3 e to the x. Okay, so what are we going to do here? We have to let, or we have to represent d plus 2y be equal to z. So this reduces to d minus 2 times d plus 2y, which is equal to z. This becomes z is equal to 4x minus 3 e to the x. Distributing, we have dz minus 2z is equal to 4x minus 3 e to the x. But what is dz? dz is similar to dz over dx. We know that. Minus 2z is equal to 4x minus 3 e to the x. Okay? This equation now is in the form of first-ordered linear equation. So on the first-ordered linear equation, we have to determine the value of p. In here, your p is negative 2. Your q is equal to 4x minus 3 e to the x. And your integrating factor phi is equal to e to the integral of p dx, which is equal to e to the integral of negative 2 dx, or this is simply e to the negative 2x. That is the integrating factor phi. And what is the solution for the first-ordered linear equation? We have our variable here is z. So we have z times phi is equal to the integral of phi q dx plus c. But based on your module number 3, we are eliminating or omitting the arbitrary constant c in the solution for particular integral yp. Bakit? Because it is a particular integral. Clear? So, now let's have another page for this. Bumakat pala siya. Sige. Lagyan lang natin sa ilalim ito. Bumabakat pala yung pencil pen ko. Wait lang ha. I-ayos ko lang. So we have the value of z phi times okay. But what is phi? So we have z phi. Phi is e to the negative 2x is equal to the integral of phi e to the negative 2x times q. Q is 4x minus 3 e to the x dx. Okay? Now, so this is equal to the integral of 4x e to the negative 2x dx minus the integral of 3 e to the x e to the negative 2x dx. Okay? So we have for the integral of x e to the negative 2x dx minus 3 the integral of e to the negative x dx. So on the first part of the differential or the integration, we can integrate this using partial integration or integration by parts. Okay? So using the formula, the integral of u dv is equal to uv minus the integral of v du. So in this integration, what is u and what is v? Okay? So we have to let u be equal to x and dv be equal to e to the negative 2x dx. So this is u and this is dv. But when u is x, your du must be equal to dx. And your v be equal to e to the u, du. So that means we have to have the derivative of e to the 2x is negative 2 dx. So we have to make this, in order for us to integrate this, we have the integral of e to the negative 2x. Your u is negative 2x, and the derivative of that is negative 2 dx. So v is equal to, we have to introduce negative 1/2, the integral of e to the negative 2x, negative 2 dx, or this is negative 1/2 e to the negative 2x. Okay? So applying the formula, u, v, we have negative 1/2 x e to the negative x, negative 2x, minus the integral of v, negative 1/2 e to the negative 2x dx. And this is negative 1/2 x e to the negative 2x plus 1/2 the integral of e to the negative 2x dx. So we have negative 1/2 x e to the negative 2x minus negative 2 dx 1/4 e to the negative 2x. So that'll be the integral of the first part. Okay? So, rewrite natin ha. Z times e to the negative 2x is equal to 4 times negative 1/2 x e to the negative 2x minus 1/4 e to the negative 2x minus 3. The integral of this is negative e to the negative x. So z e to the negative 2x is equal to negative 2x e to the negative 2x minus 1 e to the negative 2x plus 3 e to the negative x. Dividing everything by e to the negative 2x, we have z is equal to negative 2x minus 1 plus 3e to the x positive. That is the value of z. But what is z? We have denoted c a while ago with d plus 2 times y is equal to c. So, ibabalik lamang natin yung value ng c. So, we have d plus 2 y is equal to negative 2x minus 1 plus 3 e to the x. Again, distributing y, we have dy plus 2y is equal to negative 2x minus 1 plus e to the x, but 3x. So e to the x. And dy is dy over dx plus 2y is equal to negative 2x minus 1 plus 3e to the x. Again, this is first-ordered linear equation. So on this first-ordered linear equation, the value of your p is equal to 2. The value of your q is negative 2x minus 1 plus 3e to the x. Okay? And your integrating factor phi is equal to e to the 2x positive. So having this, let's go to the next part of the solution. Wherein we have the solution y phi is equal to the integral of phi q dx. Again, the arbitrary constant c is omitted. So we have y times phi e to the 2x is equal to the integral of e to the 2x q negative 2x minus 1 plus 3 e to the x dx. So we have y e to the 2x is equal to the integral. Ilabas na natin yung negative 2 ha. Negative 2 x e to the 2x minus the integral dx. The integral of e to the 2x dx plus 3 the integral of e to the 3x dx. So again, this is integration by parts, wherein we have u is equal to x dv e to the 2x dx. Your du is equal to dx, and your v is equal to 1/2 e to the 2x. So we have 1/2 x e to the 2x minus the integral of 1/2 e to the 2x dx, or this is the same as 1/2 x e to the 2x minus 1/4 e to the 2x. Okay? So we have to write this y e to the 2x is equal to -2 times this whole thing, 1/2 x e to the 2x minus 1/4 e to the 2x minus the integral of e to the 2x dx is 1/2 e to the 2x plus 3, the integral of e to the 3x dx. The integral of e to the 3x dx is 1/3 e to the 3x, so therefore this becomes e to the 2x only. So we have y e to the 2x is equal to -1 x e to the 2x plus 1/2 e to the 2x minus 1/2 e to the 2x plus e to the 3x. Dividing everything by e to the 2x, but wait, we can cancel this now. So dividing everything by e to the 2x, we have y is equal to -x plus e to the x. That is y. But this is also your yp. Okay? The solution, therefore, y is equal to yp plus yc. Your yp, rearranging natin ha, is e to the x minus x plus yc. But what is yc? Module 2, case number 1, we have yc is equal to c sub 1 e to the 2x plus c sub 2 e to the -2x. So therefore we have plus c sub 1 e to the 2x plus c sub 2 e to the -2x. And this will be the solution for example number 1 of method number 1. Okay? So that'll be for example number 1. Now let us have example number 2. So what is example number 2 of method number 1? So example number 2. Determine the solution example 2. Teka, pagpapahingin ko yung aking isang black na pentel. Let us use the blue one. Tingnan natin kung obra tong manipis. Okay? Determine the solution of d cubed minus 2d squared plus d y is equal to x. Okay? So again, solution. Letter A first. The auxiliary equation. So what is the auxiliary equation here? We have m cubed minus 2m squared plus m is equal to 0. Factoring m, we have m times m squared minus 2m plus 1 is equal to 0. Okay? So this is m times m minus 1 times m minus 2. Minus 1 pa rin pala. Is equal to 0, but na ganito yun. So we have the roots r sub 1 is equal to r sub 2, and that is equal to 1. And r sub 3 is equal to 0. Okay? So that will be the roots. So again, based on module number 2, anong case ba to? We have the same root. That is case number 2. Okay? So that is under case number 2. We're in case number 2. We have two roots, two or more equal roots. So the solution to that is y is equal to e to the r sub 1 x times c sub 1 plus c sub 2 x plus c sub n e to c sub 1 x raised to p minus 1 plus c basta ganito, e to the r sub 1 c sub 1 plus c sub 2, kasi dalawa lang naman, e to the r sub 1 x c sub 1 plus c sub 2 x plus c sub 3 e to the r sub 3 x. In this case, we have yc is equal to e. R sub 1 and R sub 2 is 1. So we have x times c sub 1 plus c sub 2 x plus c sub 3 e. R sub 3 is 0. So we have yc is equal to e to the x times c sub 1 plus c sub 2x plus c sub 3. That will be for yc. Okay? So we have e to the x plus c sub 1 times c sub 1 plus c sub 2x plus c sub 3. Okay? Now, that is YC. Now, to find YP, let's call this B na lang. For YP, rewriting the factored form of the equation, we have D times D minus 1 square Y is equal to X. So if we're going to let D minus 1 square Y be equal to Z, this whole equation reduces to D Z is equal to X, which will instantly give us Z is equal to X squared over 2. Again, the arbitrary constant C is omitted in YP. Okay, so that is Z. But Z is D minus 1 square Y. So this becomes D minus 1 square Y, which is equal to Z, is equal to X squared over 2. Okay? Or we have reduction of order again. D minus 1 times D minus 1Y be equal to X squared over 2. Again, let this time V be equal to D minus 1Y. So this whole thing becomes D minus 1 V is equal to X squared over 2. And this is dV minus V is equal to X squared over 2. Again, this is first ordered linear, where your P is equal to negative 1, your Q is equal to X squared over 2, and your integrating factor V is e to the negative x. Again, the solution is v, phi, the integral of phi q dx. So v e to the negative x is equal to the integral of e to the negative x q x squared over 2 dx. So we can write this as 1/2 the integral of x squared